Good. So we discussed about it, devices, three parts for connecting devices. First is NIC is required, and every NIC have a MAC address, that is also we discussed. Connectivity, wired or wireless connectivity. What are the wired type of devices? Mainly we are using UTP cables we are using. Okay, for cable connectivity. It means NIC is Ethernet, fast Ethernet or Giga Ethernet. Right now we are using either fast Ethernet or a gigabit Ethernet. Okay, different devices like a hub or maybe switches or routers or modems for different purposes of different connectivities. Like you want to create a LAN, then you need a hub or a switch. You want to create a WLAN, then you need a wireless access point. Okay, you want to connect from your network to outside of your network. That is what we need is a router. You want to connect to internet, then we need a modem again. And in our home, we are using Wi-Fi router, which is you can connect your wired type of and as well as wireless devices. And your Wi-Fi router having a modem, that modem is used to connect ISP to access the internet. Again, that is different network and ours is different network. Then this Wi-Fi router act like a router itself. Okay, that is all we discussed. And what is this additional points? Firewalls. The firewalls are used for protecting your network from external attacks. Okay, so it depends upon like what kind of networks are allowed to connect, what type of devices to connect, or maybe protocols are based on the port numbers or different application wise, whether it is yellow connectivity is there or not. Another security device is IPS and IDS. So IPS and IDS also software based as well as device based also there, like a checkpoint servers example. Okay, intrusion detection system, intrusion prevention system. Okay, so even you have a firewall, one way or other way, people can enter into your network and some miscellaneous type or malware, spyware kind of packets are delivered inside. Some unusual vulnerabilities, anomalies in your network, vulnerabilities or anomalies in your network. Okay, or find it will be detected by this IDS devices and preventions. It will prevent from this kind of vulnerabilities. Anything which happens or attacks on your network, it will do it. Okay, as I said, search for the proxy. Actually, proxy servers means so you are when you are communicating your other communication. So what this proxy servers will do it? It manipulate your address, means you are communicating with one address and outside when it is communicating with a different address. It change your actual address to another address. Proxy. Okay, like proxy interviews. So I'm actually the candidate. Someone interviewer interviewing me. So I will hire some proxy kind of stuff. Means instead of me, someone will take my interview. Okay, so it's like a proxy, right? So it's English or general. Same way in network also there is a proxy servers are there. So instead of your IP address and your identity, so it will give some different identity for you, different address for you. Okay, with different address, it will communicate. So another one is VPN. Again, VPN software type is there, hardware type is also there. Okay, so this VPNs also integrated with sometimes with your firewalls also. VPNs you actually connect your remote private network to your private network. Okay, for example, you are working from home, so you're in your own private, but you are connected to internet. Through this internet, you will connect it to your organization private network. So your organization private network, your own private network, but both are connected through internet. So through internet, you can connect to your private network, your organization private network from your private network. Okay, connecting private network to another private network over internet. Okay, by some protocols. Okay, using TTT, L2TP, PPTP, S2TP. So different tunneling protocols to encrypt your communication or encrypt your data transmission. Okay, it's like a stay private, even you're in a. So in a minimum requirements of network, one is NIC, cables, and devices for connecting. Now we should go for a communication. In communication, so you want to communicate between the devices. Okay, you're communicating between the devices. Okay, between the devices, they are connected, but you want to communicate between them. So they need an address. They need an address. That address, what we are using is IP address. Then we'll go to this IP address today. Okay. What is an IP address? Is a logical address. IP address is uniquely, it's not unique address, it's uniquely identify the devices in network. Okay. IP addresses can changeable. These IP addresses assigned or configured manually, can configure it. Manually you can configure or automatically you can configure. Okay. We use DHCP server to configure IP addresses to the devices automatically. So what we need is a DHCP server to configure automatically. Okay. Our Wi-Fi router also act like DHCP server. IP address, okay, having two versions, IPv4 version, sorry, IPv4 version and IPv6 version. And IPv4, which is 32-bit, and IPv6 is 128-bit. Some points I added, some are already we discussed. But again, what is the difference between IP and MAC? MAC address is physical address. IP address is logical address. MAC address, we can't change the MAC address. But IP address, we can change the IP address. Okay. Next, MAC address is assigned by the manufacturer of that NIC. IP address, we can assign ourselves like manually, or we will get it automatically from DHCP server. Okay. And we have a MAC address is 48-bit size. Bit in size, whereas IP address, we have two versions. In two versions, IPv4 is 32-bit in size and IPv6 is 128-bit in size. Okay, so these are the differences between this IP address and MAC address. Okay, understand guys differences?
Yes, sir.
Yes, sir.
Then we'll see a few points about IPv4. Okay. So I don't want to go with a deep explanation of IPv4 and IPv6 just like others, but I have a hobby of telling everything. So IPv4 is 32-bit in size, you know that one. And 2 to the power of 32 is a total bit size. It is around 4.3 billion IP addresses we are getting. Total IP addresses are 4.3 billion IP addresses. Okay. And it represents, okay, decimal format. Write in a decimal format. IPv4 is, it is, IPv4 is 4 parts. It's divided into 4 parts and separated by dot. Means like this. Okay. 4 parts means each part is 8 bits called octets. So we have a 4 octets in IPv4 separated by dot. Okay. 8-bit means each octet is 0 to 255 size, means totally 256. Each octet is between 0 to 255. It is in between 0 to 255. Okay. So this is 4 octets part. Okay. The IP address range. Okay. IP address or IPv4 range is from 0.0.0.0 to 255.255.255.255. The entire IPv4 range is divided into 5 classes. Okay. So what are the classes? Class A, class B, class C, class D, and class E. 5 classes. Anybody remember class A range?
0 to 126. 127.
127.
Yeah.
Of course, you are also correct. 1 to 126. Depends upon some textbooks. Of course, 0 we are not using. 127 also we can't assign to anyone. Very good. Class B.
120 to 1.
191.
Very good. Class C.
192 to 223.
Very good. Class D. Yeah, you can check in.
224
Yeah.
to 239.
Very good. You can check your books also, material also, no problem.
240 to 255.
Very good. 255.
Yeah.
So these are the 5 classes. And again, class E is reserved not published into the public. Okay, we cannot use it. That's why they said R&D. And class D is multicast used by, okay, it's a multicast address used by certain protocols like a RIP version 2, AGRP, OSPF, and bootp kind of protocols for using multicast. Multicasting is like a group communication, like your WhatsApp group. Okay, so those who are in that group, so they will access. Same thing like if those who are in the AGRP protocol, so they will share information in between them. Like a two address is some multicast address. Those who are in that multicast protocol, so they will get that information. And class A, class B, class C are unicast addresses. Okay, class A, class B, class C are unicast. What is unicast? One-to-one communication. Okay, 0.0.0. Okay, is a reserved IP address. So we cannot assign to any device. Of course, that's entire 0 series, can't use it. 127.0.0.1 is one of the important one. Reserved. It is also reserved IP for loopback or local host address. What is local host address is? There 127.0.0.1.
Excuse me, sir.
Tell me.
Screen is not.
Screen not visible. So we'll do one stop sharing and I will share it again. Now
Yes,
it
sir,
is
we can
visible.
able to see this.
Kirti, can you see now?
Yes, it's visible.
Okay. Sometimes network issues also, it will freeze the screen. Okay. So what is the purpose is self-testing, like ping to self-testing ping to 127.0.0.1. Okay. Self-host service access. Okay. So from my host only, I'm accessing certain services, then you can use it. And again, this entire series, so we are not using. Okay, we cannot assign to any devices. Okay. We are all done practices like which is your IP and all, but I am going to subnet mask. So quick review. Okay. What is the subnet mask? Subnet mask system. Our system means our computer or your desktop, laptop, mobile phone, or your server. All our systems are devices, you can say. Okay. System use the subnet mask to divide IP address into network and host portions. Okay. Next, tells network ID. If both devices network portion is same or network ID is same, the devices will communicate each other. Okay. So that is the condition. Okay. So we have a class A, class B, class D. So these are the class A and class B and class C. So network portion is for class A is the very first portion is network portion, remaining are first portions. Class B, first two are network portion, remaining is first portion. Class C, first three are network portion and remaining is first portion. By default it is. Now, anyone can tell me what is the subnet mask for class A? Class A subnet mask 255.0.0.0.c. Class B subnet mask. Now you tell the misters B and C. Check textbooks, notes, anything. Are we recording? Okay. This is the subnet mask. And I'm adding one more information, that is, so in this one only, based on this network and host, means you take one class C network. So you take one class C network. So maximum number of host is one person, means number of host bits are 8 only. Okay. And it means in one single network, you can connect 254 devices in the network portion. Okay. In a class B, you can connect 65,534 devices in single class B network. In a class A, we can connect 16,777,214 devices we can connect in one single network. Okay. Then what is subnetting? Dividing single network into multiple network. Purpose is to save number of IP addresses not used. Okay. And cost. Mainly for public IP addresses. Okay. Just for point two. Yeah. Then what is this private IP address and public IP addresses? To access internet, we need public IP addresses. Okay, to access internet, we need a public IP. Okay, without public, you can't connect it to internet. Okay, and what is private IP? Private IP addresses are not routable in public, used in private communication only, used within the private. In the private network. No need of registration, payment to use private IP addresses. Okay. Need pay to use public IP addresses. Need to pay. Need to pay. Of course, registration is also there. That register what public IP addresses you are using. And private IP addresses. This private IP address ranges from again class A, from class B, okay, class C. Anybody remember private IP addresses ranges? This is entire range, single network. Okay. It's only one single network used for a private purpose. So you can use it, I can use it, anybody can use it. No need to pay. But with this IP address, you can't communicate in the public. 170.16.0.0, 172.31.255.255. So these are all entire range of private IP. So this is a totally 16 networks are there. 172.17. Another network. Okay, up to 172.31 network means, so around it is 16 networks are there. 15 or 16 we are getting, like you have to count from 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, and 31. That is totally 16 networks we are getting for a private. So these are 16 different networks. And here it is same 192.168.0.02, 192.168.255.255. This entire range is private network only. Here it is 256 networks you are getting. This is one private network. Next private network is like this. Okay. And This is the 192.168.255 dot network. So totally it's like a 256 networks we are getting from like 192.168.1 dot something that is private. Okay, like that. Again, 2 dot something. So different private. Okay, totally 256 private IP addresses we are getting. Okay. Automatic private IP address. This is also there. Okay, automatic private IP address. If the device or failed to get IP address from DHCP server, failed to get IP address from DHCP server, the system itself assign an IP address from automatic private IP address range. Okay. And what is this IPv4 range? Is 169.254.0.0 to 169.254.255 to 55. It's a total range, but it won't assign that first and last now. So that's why it is what I'm typing. This is actual range. That's total range. This is actual range. Okay. Between any of these, it will pick up any IP address based on the your MAC address. It will assign some IP address, automatic private IP address. Guys, then what are the public IP address? Other than private range, other than this private range, other than this IPv4 range, other than unused IP addresses, means this, other than these ranges, okay? It means 0 series is 127 series is, okay? And this 10 series, 127.16 to 170.31, the total ranges, 192.168 series, entire 192.168 series, and IPv4 169.254 series. Other than this, all remaining IPv4 address from class A, class B, class C, all are public IP addresses only. All are public IP addresses. Understand?
Yes, sir.
Then what is this NAT and PAT? Okay, without public IP address, you can't communicate to the public, right? But you want to connect to the public, but you have a private range in your network. You are already having a private range. Okay, then how to connect it using different techniques called a NAT and PAT techniques. NAT, network. Anyone?
Network address translation.
Very good. PAT.
Port address translation.
Very good. This PAT also called as NAT overload. Okay. So here it is. NAT maps your private IP address, means inside IP address to, okay, public IP. or outside IP. Okay. Inside one IP address, one network. Outside other IP address, other network. Still maps. So when we devices, we are communicating, so we need it. In NAT, one private IP to one public IP address mapping. Means you have a 10 private IP addresses are there. Okay, then you need a 10 public IP. Again, cost. Again, cost, right? But in organizations, think about enterprises, big organizations, they have a different servers are there, right? You are accessing google.com, right? Google, Gmail, Yahoo, so many things you're accessing, right? So even Google itself having so many services like www.google.com on server, right? Inside, maybe it is private. Inside, we don't know what is this private IP. But outside public means what public IP address we are accessing, that we can know it. Okay. So www.google.com, docs.google.com, mail.google.com, what is that? It's a class room.google.com, meet.google.com. Okay. So different servers we are connecting through public. It means they need, for example, Google having a 10 services in the public. So they need a 10 public IP addresses required. If they have a lot of services are there, so we'll see from here. If you go, click here, see it is, they have a Gemini, YouTube also integrated inside, photos, okay, translate, shopping, play, finance, flights, okay, sheets, docs, books, classroom, okay, Google Ads, okay, one travel, store, forms, okay, Google Forms, okay. So like this password manager, like different services are there, different servers are there, for example, okay, 20 services required. Google site is also there, another one, okay. So like I am having my own site in Google. You can create yourself also. You can type Latif Tech Notes. So on Google site, just like it's kind of blogger only. Okay. So you can put your notes here. You can able to access from anytime, anywhere kind of stuff. This is a simple one. Okay. So different information. Actually, I implemented some part and later I leave it. Okay. So I have to implement lot of things. So later, okay, leave it. So I didn't implement it. Forms and docs. Okay, different test forms and all I created. Okay, this is like a Google site. Okay, so different services are there, so different IP addresses required. Maybe you have written LMS, we have LMS implementation, different servers in our Savantis data center. So they need direct connectivity to public. So in a NAT, what we do it, so we'll map to multiple public IP address. That is clear-cut NAT we are using. But in your home, in our home, so you have a 5, 6 devices, 10 devices. Your laptop is there, mobile phone is there, your brothers, sisters, mobile phones are there, their laptops also there. Your parents, nowadays, everybody having one mobile phone or two mobile phones, tabs, laptops, smart TVs, okay, Wi-Fi printers, all we are connecting in locally. But all we are connecting to outside, like your smart TV also connecting to outside public, right? So for that one, again, more public IP. Public is paid services. Okay. Public IP means it's a paid services. You have to register, you have to pay for use. Again, it is very costly. So your internet is become very, very costly then. Now, what is this solution is port address translation. Port address translation. It maps multiple private IP address to single public IP address using port mapping technique. Okay, using port mapping technique. It means, so you have a 10 private IP addresses and you can access through one public IP address only. Okay, so between the port mapping is when you're connecting, so different port numbers are assigned using one single public only, you can able to communicate. If you want to test, take 5-6 systems, 2-3 systems are enough, 2-3 systems are enough. Okay, so go to this 2-3 laptops in same Wi-Fi. They should connect it to same Wi-Fi only, first of all, same Wi-Fi. And go to Google browser, type what is my IP address. Type what is my IP address. So in a Google browser, it will show us your IP address is a public IP. It will appear only public IP because Google don't know your private IP. Okay, see, only your network knows only private IP. Google knows your public IP only. So one system, write down in one system, what is the public IP, and check in another system. Most possible, it will show us for all system public IP is same because you are connecting with one single public IP address. Of course, in your router or maybe in the ISP provider, what they will use it, they'll map multiple private to the single public. Not only single, but there's a 50 privates are there. So they'll map it to 2-3 public IP address or 5 public IP addresses on. So it reduce the cost. Okay. So dynamic public IP addresses, they will assign. But everything is logs are shared into the servers. Means which private IP, which port, which public, which port. So like that they will maintain. So when you're sending and receiving, that's why you're already in a secure network. If someone knows your private IP, or someone knows your MAC address, or someone knows your public IP, they can't reach your system directly with your private IP or public IP or MAC address. If someone trying to attack on your system, only one way is you are opening some websites. Okay, some vulnerability websites are there. You're opening websites, tiny URLs. Best example I will tell. Best example, through WhatsApp, people say Amazon link. Okay, that Amazon link, when you tap it, so there is a wheel of fortune type. So the wheel is done, and you tap on it. So then wheel runs. It will show you win a iPhone. Log into your Amazon link. So it will redirect to your Amazon app. Okay, so when it is redirecting, you log in and automatically someone is gaining or your they will try to get your Amazon access. They will get your Amazon username, password, or what are the saved cards and all things. This is how it is compromising. Whether you use a VPN, not a VPN, there is nothing is like that. Okay, so only thing is if you are open this kind of vulnerable type of websites. So mainly these torrent websites, torrent downloads, okay, pornographic type of websites, okay. So mainly like when you click something like advertisement come, all are dangerous, redirect to websites, even duplicate websites, okay. Duplicate, like you search for something like a Facebook, it's duplicate Facebook can be there. Passport, so I have seen passport duplicate website. Okay, so this duplicate websites are there. So you also please check it that one. People share a link to open it, and then you'll get some information. So those tiny URLs kind of stuff, already links are there. So when you open it, your details will share it. You downloaded torrents through torrents. Third-party applications you download through torrent or any third-party applications from other website. Okay, for example, you want to download VLC player. Go to VLC, that real website, and download it, no problem. But same VLC, if you are download from third-party websites, so in that maybe there is a possibility in that application itself, some malwares or spywares are inside. You install that application, the spyware hook to your registry, your system registry. So then just by hooking, other guy will enter directly. Okay. You open gmail.com, you send a request to Gmail, then only you are getting directly. Gmail cannot send to anything to you until unless you send a request. Same formula. You open some website, then it is connected to someone. They'll enter into your network. Okay. That's what it is. So be secure browsing is very important, guys. So make sure that is you know that site, the link, and that is no harmful in it. So then you can access. Otherwise, don't open it. Third-party apps, for example, your mobile phone also. People are download APK files. Okay, for watching some movies, series, free. Okay. No, you download it. Possibility there is some homemade duplicate application are there. Okay. So you downloaded it and you open, enter your mobile data, someone will happily access your data. Okay. So be careful because sometimes you have a personal data are there. It may be your personal videos, pictures, or your cards details, bank apps. Everything is in mobile nowadays, right? So when you're doing it, so you don't require a VPN to protect you. You require a simple, don't open this kind of third party kind of stuff. Okay. VPN. So VPN is most dangerous, guys. If you know the VPN service provider, for example, you are purchasing some antivirus, McAfee or maybe Malwarebytes or some Airtel. Airtel is also providing VPN. So that is one kind of service because people are in a want to use a VPN. That's for them. Okay, genuine service provider is there. Okay, you check it. Well-known organization, then you can use it, no problem. I'm not objecting it. Okay. But so whatever it is, free VPN, 10 rupees VPN, free VPN means maybe you're connecting to maybe real hackers. Okay. So that is different. So when we really having a time, how it is happens with the VPN, also we do it. Okay. Actually, the VPN routing is used by hackers only. But we are into that position. It's not required any kind of VPN to protect your system or a network. Just you need an antivirus. So proper antivirus or update your system Windows Defender properly, regularly update your Windows Defender. Okay. And do not you open this kind of third party sites or third party applications installation. Don't do it. Use the from genuine website. Okay. Genuine download your application from original websites only. Okay. Yeah, that's it. Anything? Anybody say anything?
No, sir.
Understand that last points?
Sorry.
Mm. So we'll see this IPv6, IPv4 differences, and then we'll cut it today. So tomorrow when we connect, please read other things also. I'm happy one is like your guys are giving an answers. You're telling one by one, so it means you read and you are very confident in it. Okay. So tomorrow we'll
Hello, sir.
discuss about OSI model. Final. Yeah, tell me.
Sir, can we have these notes which you are typing like we need
Yeah,
to
I
know?
will share it definitely. This is very quick revision, right?
This is like actually very understanding this so that we need.
Okay. This is a very big one. Means so a lot of things are there. You feel fear. So I have to read all entire thing. Okay. But you have to keep it this one also aside because this contains pictures, the explanations, depth explanations are there. Okay. So definitely this is for quick review. Okay. So we'll discuss about IPv6 and we see the differences and we close today. And then you guys compulsory check the OSA model, port protocols and port numbers and some other details in our actual notes. So go through it. So tomorrow first we'll see that one because there are direct questions, nothing, direct questions. Okay, should not fail in this main questions, and I'm happy that is everybody is reading. Okay, so compulsory it is. We'll see. IPv6 is 128-bit, whereas IPv4 is 32-bit. Okay, and it is 3.4 into 10 to the power of 38. That many different. Okay, it's actually 3.4 billions. Actually, it is like a decillions of IP address we are getting. It's IPv6 is very big one. Okay, very big one. Actually, it is represent in hexa format. Hexadecimal format. So IPv4 is just a decimal format, hexadecimal format. Okay. So totally, how many hexadecimals are there? 32 hexadecimals are there in a IPv6. 32 hexadecimals numbers are there in a IPv6. Okay. These 32 hexadecimals divided into, okay, these are divided into 8 blocks. 8 blocks. And in IPv6, how many blocks? 8 blocks. Okay. Divided into 8 blocks. Okay. Each block contains 4 hexa numbers. Okay. 4 hexadecimal numbers are there. Okay, so 4 into 8, it is 32 hexa numbers. Okay. 8 blocks separated by colon. Colon. O-L-U. Colon. Okay. Colon. So this is hexadecimal. You can type an example here. So I'm giving some example of how this R look like, just for example. Up to A, B, C, D, F only. Don't put G, H, H, A, K. Okay. Remember, 8 blocks. Already 4 blocks. This is 3 more blocks to go. One more block to go. This is how it is looking. I can give more examples. See, I'm giving anything name colon A. Okay, this is also and a few small differences. Okay. In IPv4, we have 0.0.0.0. In IPv6, we have colon. Same for IPv4. We have 127.0.0.1. In IPv6, we have a colon 1. Okay. And IPv4, okay, so we'll see that one separately. Okay. Small difference I'm adding, so maybe I thought I will forget. Again, in IPv6, not divided into classes. Okay, IPv6 not divided into classes. It's a tricky one. Okay, because how many classes in IPv6? Actually, that entire IPv6 is not divided into classes. But there is a classification is there. Classification is there. Okay, for different purposes. One is global unicast. It is a public IP address. Okay, public IP address. Actually, people write like this /3. Okay, so some people say only /3. Some people say like this. Okay, this is the okay. Actual ranging is 200 colon something like it could keep on goes, but the starting one only it is the last one. Okay, this is the total ranges belongs to public IP addresses, unicast IP addresses. Then private IP addresses separate. Private IPv6 addresses. Also, there is a range. Okay, it's a small confusion. That's why I am going back. Okay, so only small difference. This one and this one. Okay, remaining no confusion. FD also there. Where is FD? Okay, this is FC, but FD also there. Okay, FC colon FC00 colon /// I think it is 7. 7. Not double colon 7, it's just colon 7 because this contains so many other changes also. It is non-routable in public. Private IP is not routable in public. Without public, you can't access. So private is only used in private network. No need of registration. Anybody can use private IP. My favorite is link local. Link local. Okay. Link local. It is FE80. Okay. FE80. It is non-routable in private and public also. Okay. For example, if you are using routable, non-routable in public as well as a private. And why it is much of interesting? System assign link local IP address to itself. Okay. It's a system assigner, system generated. It's a system generated. Actually, it's self-generated based on MAC address of system. That system. It means self-assigned. It is self-assigned. For example, you take my system, command prompt also, okay, no problem. IP config, just IP config is enough. See, if you see, this is my link local IPv6 address. It is assigned by my system itself. See, my system itself. Not by anyone, not by any services. Self-generated IPv6 link local IPv6 address or system generated IP addresses based on the MAC address of the system. You can use to communicate within the segment. I keep on using segment, but no one is asking what is segment. No one is getting doubt what is segment, in the segment, outside of the segment, in the network, outside of the network. No one is asking. It's interesting. So difference between private IP and link local IP addresses. So your private network is, okay, good private network it is. This is your private network. It means, for example, this is a network. So where you are connecting devices like this. Okay, you are connected devices. You created a network in your organization. This is one network. This is called a one segment. Okay. And you have another network. Both are in a private only, in your organization only. So no public, no internet connection it is. Okay. This is also your own private network only. Your own intranet only. This is another network in your private network. Separated. Okay. In case this is one network, this is another network. So this is called one segment. This is called another segment. Now we are having two segments. We are connecting directly with some cable from this switch to this switch, like a extended star range. Logically same network, physically now both are same network. Meaning is now both combinedly single segment. Both are combinedly single segment only. So earlier separate segment. Now it is combinedly single segment only. Okay. Understand guys? Two segments.
Yes.
So this is one network and this is another separate network. It's logically separated, physically also separated. For example, in that cases. So you want to make a communication between two different networks. What we need is a router. So logically separated, physically also separated. But both are in the same place only. So for example, okay, different networks. You want to make communication between them without changing your logical address or a physical direct physical things. Okay, physically separated, logically separated. They're maintaining physically. Okay, so this is separate network. This is separate. Means this is one segment. This is another segment, and you are making communication between them using simple router. So both devices, both networks are communicating each other. Okay. Again, this is two segments. Now it's not one segment. Now it is two segments, but both are private. Both are LAN. Okay. Both are LAN. It's totally LAN, totally private. But two separate networks means two segments. Okay. Understand different? Two segment and one segment. Link local. That FE80 series is there now. FE80 series net. IPv6 works within the segment only. Means within this one only, people can communicate using link local IP address. IPv6 link local IP address, they can communicate each other. It same goes for this one. In this network with their link local IP addresses, so they can communicate each other, no problem. Okay, so within this segment, they can communicate, but they cannot communicate from this segment to this segment using link local. Link local only works within the segment only. So in the private, you want to communicate between the segments, you need a private IP. A private IP, FC00 model. Okay, you have to use this FC00 from communicate between. Means it can route in the private. Private networks can route in the private. Okay, so it's a concept. And you are connecting to the public. Then you need a global unicast address to connect to the outside of the network, public network. You are want to communicate inside your private, in your LAN, private IP is required. Within your segment, non-routable type, it is link local is enough. So actually you are fighting for a IPv4 learning. Okay. When I learn about IPv6, when I know about this, I took a lot of time, like 2 months time to understand IPv4, subnetting, faster subnetting calculations, host person, network person, number of hosts, number of things. So full-fledged I prepared it. Then I learned about IPv6. I understand it is waste of my 2 months time because IPv6 no need to be install anything. You don't need to require any DHCP server. It works in stateless mode. Okay. IPv6 works in a both stateless and stateful mode also. Okay. And IPv6 within a segment, no need of assigning IP address because by default, every system has its own link local. Your system having one unique link local IP address. My system having one link local. But only thing is within the private, we can communicate. Within a segment, we can able to communicate. Okay. Multicast. That is an advantage of IPv6. IPv6 advantage is very big IP address. Very, very big. Means more number of devices. In single network, almost like a 2 to the power of 64. IPv4 is 2 to the power of 32 only, total IP. But in IPv6, for only for host, it is 2 to the power of 64. Okay. It means so many billions. Okay. Billions of hosts we can connect in the single network. In IPv4 also 16 million. But in IPv6, one single network, billions of devices we can connect it. So very big one. Okay. And it is secure. It is secure, regional based. Okay. ISP identification, region, and security integration is also there in the IPv6. Secure. Compared to IPv4, IPv6 is more secure. Okay. And large processing is required because bigger hexadecimal number. So hexadecimal numbers easy to convert into binary. Compared to decimal to binary conversion, hexadecimal direct conversion. So if I want to convert this into the binary, very easy. Okay, how to convert? So F, okay, E, 8 zeros. See how much fast I converted. If you take a decimal number, very simple. It's take time. At least somewhat time it is taking. Okay. So you take some very simple number. I will take 78. It will take time. It's not much simple like it not happens. But IPv6, so direct conversion from hexadecimal to binary. So that's it is also faster. Even it is a very bigger, for binary conversion is very faster. And of course, you need a more bit space is required because it's a bigger the cells. And different ways of IPv6 writing is also there. FF00. Okay. And no broadcast. Any cast is there in IPv6. Okay. Again, no broadcast. Any cast. IPv4 broadcast. IPv6 any cast. Okay, no broadcasting. No broadcast IP addresses. So again, IPv4 broadcast. IPv6 any cast. Okay, so it is a broadcast. This is any cast. Next step. No subnet mask. Yes. Okay, we do not need to learn about subnet mask 255.0.0. Not required here. But network and host portions, portions divide using prefix slash notation. Notation. Okay. For example, generally, okay. Example, you can say FE 80 colon some number. I need some number. Again, command front IP config. I'll take some number from here. Oh, I can type it, no problem. But so this is 1 block, 2 block, 3 block, 4 blocks. 64. So meaning is this is the host portion, and this part is network portion. Okay. So this is host ID. Okay. So this front one, it is network ID. So like network ID comes like this, FE 80 colon 0 colon 0 colon 0. Okay, this is a network. Okay, network portion. Okay, so this is how it is. So no subnet mask, but network purpose. Network, which is host. Identification is this slash notation, like a prefix. Any questions? Anything we missed in IPv6? Okay. Okay. Again, IPv4, IPv6 differences. IPv4 32-bit. IPv6 is 128-bit. IPv4 4.3 billions of IP addresses. 4.3 billions of IP addresses. IPv6 3.4 billions of IP address. Exactly say 3.4 into 10 to the power of 38. IPv4 represented in decimal format, and IPv6 is hexadecimal format. IPv4 is divided into 4 octets. Okay, IPv4 divided into 4 octets separated by dot. IPv6 is divided into 8 blocks separated by colon. And we have a 32 hexadecimal numbers are there. And each block contains 4 hexadecimal numbers. There's so many things about IPv6 are there, how to write, rewrite IPv6 formats also there. Just I'm giving an example only. Okay. In IPv4, 0.0.0 is reserved for unknown IP address or used by certain services. In that is represented in IPv6 colon only. In IPv4, this is important. In IPv4 127.0.0.1, which is loopback or local host address used for self-testing, self-host accessing. In IPv6, it's colon 1. So your loopback or local host address in IPv6 is colon 1. In IPv4, that complete range 0.0.0.0 to 255.255.255.255, that is a total IPv6 range. Okay, the total IPv4 range, total IPv4 range is divided into 5 classes: class A, class B, class C, class D, class E. But in IPv6, it is not divided entire your IPv6 into classes. So there is a classification, means there is a certain ranges are given for a different purpose use. Okay, directly there are giving a range for public access purpose. Public IP address ranges are given, that is called global unicast. And there is a range is given for a private IP addresses purpose. which is non-routable in public, but it is used in a private IP addresses. Private IP range is given. And one more is, that is very interesting one, is link local. System self-assigned or self-generated IP address based on system MAC address itself, or your adapter MAC address based on your adapter MAC address. So your IP address is generated by system itself. It is not routable in both private and public, only works within the segment only. System generated. Within the segment, you can able to communicate each other without separate IPv4, IPv6 IP address assignment. With using a link local within the private, within your segment, you can communicate each other. And of course, there is a multicast IPv6 address is for multicasting purpose. And in IPv6, we don't use broadcast. In IPv4, we have a broadcast. In IPv6, we have a unicast. So broadcast means send packet to everyone, all connected devices. IPv6 is unicast. Unicast means only the connected device IPv6 is enabled. If IPv6 is enabled, then only ncpa.cpl. So if IPv6 is enabled, then only it is send that packet to everyone. See, it is IPv6 is check mark, means in this adapter IPv6 is enabled. Okay. If you see, there is obtained automatically, there is no IPv6 based, but if you see the details, okay, link local is appear. Point is, if that IPv6 is enabled in the devices, then only it will send that packet to that device only, not to everyone. Only IPv4 enabled one, it won't send that packet. IPv4, IPv6 is enabled, so then it will give the packet. IPv6 only enabled, it will give the packet. So that is called a unicast. Okay. And no separate subnet mask like IPv4, but we use prefixes or slash notations to represent network and host portions. We can rewrite like that also. We can rewrite like a to represent the sent network and host portions of IPv6 address. Okay, we use prefix prefix like this, means slash notation. Okay. In IPv4, the slash notations also use for this things. I didn't write that slash notations here, but this is enough. Or maybe if you need, I will add that one into this notes. Okay. Any doubts, questions? Where to say? Desktop, any HCL, SDs, so many are there. I will create a folder for you. It's folder. Okay. Sometimes I need to concentrate on your patch. Okay. So I saved it, so then I can able to send it to you. Yeah. Where is the saving? Where I saved it, I will go to save as. What is this? November HCL ID. Where I created? I saved in different place or different number. What it is happening? HCL SD. I saved in different name and it is saving in different place. Now, networking and here is division. So it's installs division. That one part one only. Now part one, no, I will add it tomorrow again. So then it will be okay. This one is something is earlier. I don't know why it is so changing of its name. One of my favorite document I created, but I not fully updated. But max to max it is there. If you can able to find on my screen, the file name is H8. Okay. IPv4, IPv6. This is H6. 8. This is the one. Okay. So there are a lot of things are available. Okay. Anybody is having interest, so you can also go through once, but not fully updated. Not fully updated, but lot of things are there. Okay, that's it for today, guys. And prepare OSA model. Okay, OSA model, protocols, port number.